When looking for ways to prove that triangles are congruent to one another, you only have the ability to make marks showing that sides are congruent or angles are congruent based on actual theorems and definitions rather than just whether things look like they might be congruent. When we're marking congruent angles, we mark those with arcs. So single arc with a single arc, double arc if the singles have been used, and triple arcs if necessary. There are several ways that you can get angles congruent to one another. We know that if we have an isosceles triangle, meaning two legs are congruent on that triangle, then when the sides are congruent, the legs are congruent, that makes the base angles congruent. So if you see a triangle with two tick marks that match, and you know those two legs are congruent, you may mark the angles congruent. If AC is congruent to segment CB, then you have a theorem that says angle A has to be congruent to angle B. Vertical angles will always be congruent to one another, so angle ABC will always be congruent to angle DBE. You can mark those arcs, angles with arcs. Sides were congruent, forcing angles to be congruent, and vertical angles are always congruent. Two angles formed by intersecting lines, the only thing that they share is the vertex. Those are vertical angles. If you have parallel lines, the lines could show arrows going in the same direction or opposite directions with the same number of arrows. If you have parallel lines cut by a transversal, then your alternate interior angles will be congruent, corresponding angles will be congruent, and alternate exterior angles are congruent. But with most of these diagrams, the two angles that will be congruent will be alternate interior angles. It may be helpful to extend your sides of your triangles so that you can see the parallel lines and the transversal. So angle C is congruent to angle D. When you trace the lines, the parallel lines and the transversal, it lights up the two angles that are congruent. If we trace two more lines and a different transversal, those same two lines and a different transversal, we can see that these two angles, angle E and angle A, are also congruent. So we could put an A by those arcs and an A by the two single arcs. And once again, your vertical angles are congruent. Angle bisector is the other way that you can get angles congruent. If ray DJ bisects angle FDE, then angle FDJ has to be congruent to angle EDJ. So if you see anything mentioned in a proof that a ray or a segment is bisecting an angle, you know that those two smaller angles must be congruent to one another. There are several ways to get sides congruent. We denote that sides are congruent by using single tick marks to show two sides are congruent, double tick marks to show others are congruent or something is congruent to itself if it happens to be a shared side, and triple to show that the third pair of sides are congruent. The converse of the base angle theorem says that if angle D is congruent to angle F, then the legs have to be congruent to one another. So segment DE has to be congruent to segment EF. If angle D is congruent to angle F, then segment DE must be congruent to segment EF. The reflexive property says that if one side is in both triangles, it must be congruent to itself. Like a reflection in the mirror, you see yourself in the mirror. Segment AC is in both triangles, so segment AC is congruent to segment AC. Other ways to get segments congruent is by using the definition of midpoint. If C is the midpoint of segment BD, then segment BC must be congruent to segment CD. I think of this as someone trying to butt into someone's conversation. C wants to get right smack dab in the middle of B and D. So the distance between C and D and the distance between C and B have to be the same. Finally, we have our segment bisector definition, and if segment AC bisects segment BD, then segment BC and segment CD have to be congruent to each other. It's just like midpoint, we're just using a different word, bisector. Likewise, point C could be the bisector of segment BD. Once again, segment BC has to be the same length as segment CD. Once those triangles are congruent, all the other parts have to be congruent to each other. So we can use the abbreviation, corresponding parts of congruent triangles are congruent, CPCTC, or we can simply say, hey, I have congruent triangles, so I have congruent parts.